focus on these two things. One will be the quantifiers, one will be the truth table. Basically some logical expressions should be there. We have to think about this. We have to actually get the thing properly about this expression based on the truth table. So before we start, what I can do, I'll start with the truth. I'll take few connectives, the logical connectives like conjunction, disjunction, negation, then there will be XOR, XNOR, these kind of things are there. So first of all, we have to get the truth table for all of the symbols or all of the connectives, then we can actually go forward. So let's start. I'm sharing my screen. Hope you can see this now. So okay, so let's start. This is the question. On the left side you will get the question, and on the right side I have taken a blackboard. Here I'll actually do something. Now my suggestion will be just take a pen and paper, because the procedure or the concept I will write here, just take a note of that. Whatever the question I am solving, don't do that. If you want, you don't write those questions, but the formulas, the procedure, whatever I am writing here, just take a note of that. It will help you during the placement, basically when you will take the aptitude test. So definitely this kind of question you may get. Okay, and I think that none of you know me actually, so don't worry. It's only a course for 2 classes, today and tomorrow. These 2 classes I'll take, and I'll teach some basics about discrete mathematics. Okay, so let's start. So what we'll do first, we'll actually first, okay, let me admit all the students who are actually in the lobby, and now we can start. So as I told you already, I'll start with the truth table. Now logical expression jo hai, in the logical expression, the connectives, basic connectives you will get, those are these. This is called the conjunction, okay, that is disjunction, and that will be the negation. Okay, or in another way we can say that is and. This is the symbol for or, and this is the symbol for not. Okay, so these 3 are the basic connectives in the logical expression. So first of all, we have to get the truth table of them, and whatever the remaining expressions or remaining symbols are there, they can be represented in terms of only these 3 things, 3 connectives. Okay, now let's start. What is this? This conjunction. So this means when we have taken 2 propositions and they are connected by this symbol, then the whole proposition will be true if both the propositions are true. Got it? Like I have taken 2 propositions P and Q, and I have taken the symbol here between them. So I can say the whole statement or whole proposition will be true if individually P and Q both are true. But for this symbol, this disjunction symbol, actually, if we use this symbol between any two propositions, then if you want to get this whole thing as true, so we need at least one of them is true. If either P true or Q true, minimum one is true, then this should be true. This is the negation. What is this? So that will come just before any proposition. It can give you the negative sense of a proposition. Like if you have a proposition P, negation of P will give you the negative sense of that proposition. Okay, now let's start with the truth table of these 3 first. Now if I take 2 propositions together, so actually we will get total 4 combinations or 4 possibility between them. If we consider that any proposition will have 2 options, either this will be true or false. So if we take 2 propositions together, we will have total 4 options to choose. Like I can write in this way: true, true, false, false, and there will be true, false, true, false. So suppose I have taken a truth table like this. Now if you are thinking that it will take some time if we write T and F there. In place of T and F, you can actually use 1 and 0 also. I think it will help you. I mean, it will reduce the time, whatever the time you are using to solve this kind of problems. Okay. So you can get the combinations like this. When both are true, there is P is true, but Q is false. This means that P is false, but Q is true. And for the last row, you can see that both P and Q, they are false. If I take this conjunction between them is, so what will happen, as I told you, that this expression will be true when both the propositions are true. And that scenario you can see on the first row where P and Q both true. So only for that case, result will be true. For all the other options, you can see that none of the row are containing both the proposition P and Q are true. So that's why just use the symbol F there. So that is the basic truth table for this conjunction symbol you can use. Now take the next one, P, this junction Q. And as I told you, this whole thing will be true if at least one of them are true. For the first row, both are true, definitely result will be true. For the second one, P is true, Q is false. So at least one is true, you can see. That should be true. For the third row, Q is true, P may be false, that does not matter. As I told you, we need at least one proposition is true. So that's why this will be true. But for the last row, you can see both P and Q are false. Only for that case, we can use the symbol F there. Now, if we find the truth table for the negation of any proposition, so whatever the symbols, whatever the possibility we have taken, it will be just opposite of that. Like negation of true, that should be false. Negation of true again, that should be false. Negation of false, that should be true. That should be true. So in this way, we can actually get the truth table for first three basic connectives: conjunction, disjunction, and negation. Now, another symbols, another connective you can see in logical expression, that is the most important actually formula, most important symbol, that is called the conditional connective. Now, if I take two propositions P and Q, and if I want to find the truth table for P conditional Q, this one, so this thing will be true when basically, in another way we can say this thing would be false when the first one is false, first one is true but second is false, because P implies Q. That means if P is true, so Q, that means if P happens, definitely Q will happen. So when this thing will be false, that P is happening but Q is not happening, so only for that case we can get the result as false. So exactly same scenario we are getting in the second row, when P is true but Q is false. That means P is happening but Q is not. But what is that this mean by implication? That when the first one will do, the first one will happen, definitely the second one will happen. But for the second row, you can see first is happening but second is not. So only for that case, the result will be false, and for all other possibilities, the output will be as true or tree. Okay, as I already told you, in place of T and F, you can use 1 and 0 also. Now, the next thing we can get, that is the biconditional. But before we go to there, so few things you should remember from here. What is that? That here P conditional Q, one connective we have used, but as I told you, three basic connectives are conjunction, disjunction, and negation. So there must be some formula or some law which can break this conditional connective into a simpler form. And one such law is there, that is called the conditional law. So you can make a note of that, the conditional law. What is the conditional law? That P implies Q, this thing, this expression is equivalent to negation of P, disjunction Q. So that's a very useful law. By using that, we can convert a symbol, we can convert an operator implies or conditional into our basic form, like with respect to negation and disjunction, right? Now, the next symbol we should know about, that is the biconditional. So biconditional mean what? That this P implies Q and Q implies P. If these two things are happening simultaneously together, we can say in place of that we can use the biconditional symbol. So we can use another law. We can write another law. That's the biconditional law. That is the biconditional law. What is that? And the symbol for that will be this double arrow. So if we use the right arrow, that is the conditional symbol, basically conditional connecting. If we use both arrows, that is the biconditional symbol. So that means actually P implies Q and Q implies P, both are happening together. So as I told you, if any two event or any two proposition are happening together, so that means we can use the conjunction symbol there, because the concept of conjunction is that both the things are happening together. So I can use this one, P conditional Q conjunction Q conditional P, this one. Now here actually you can use this conditional law to break it, I mean to make it simple again. Like in place of P implies Q, I can write negation P disjunction Q. In place of Q implies P, I can just use the reverse of that, that is negation Q or P or disjunction P. So that kind of thing we can use. But if we write the truth table for that, P conditional biconditional Q, what will be that? It will be like this, that when both the things are correct or both the things are false, only when the result will be true, and for all other cases result will be false. Now exactly that scenario you can see here on the first and the fourth row, where both the propositions are having either true or both the propositions are false. So that means in that two cases we have to get the output as true, and for all other cases output should be false. Got it? So biconditional mean when two propositions having same input, result will be true, otherwise result will be false. Now another operator, another symbol, another connective you can get, that is called exclusive OR. Next is that exclusive OR in simply we can write XOR actually. XOR, this is called XOR. What is this exclusive OR? That when exactly one thing is true, then the output we can get as a true result. So the symbol for XOR is this one, this plus and a circle. The plus symbol will be inside the circle. So here two propositions P and Q are there. If I write P XOR Q, that means the result will be true when exactly one of P and Q are true. Now if you look at the input set here, you can see for the first row both the propositions are true here. So result should not be true, because result should true when exactly one will be true. For the second row, you can see P is true, Q is false. That means here exactly one is true. So then only you can actually write here the output as true. For the third row also similarly same kind of scenario we are getting. P is false but Q is true. So exactly one is true. So the result should be true here. And for the remaining two possibilities, both are true and both are false. So that means we can put here the result as false. Now you can see here is a connection between these two columns. I mean these two connectives, the biconditional and XOR. You can see that the column for or the output for XOR is totally opposite of this biconditional. So opposite means what? We are actually taking opposite in the sense of negation. So we can say here from here that P biconditional Q is the negation of P XOR Q. That's all. The next one is the exclusive NOR or XNOR. So we can write exclusive NOR, or this OR should be actually capital OR. This is the special thing. This one, exclusive NOR, or simply we can write XNOR. This one. Okay. Now what is that? That is just opposite of exclusive OR. So basically we can say that is negation of exclusive OR. So negation of exclusive OR is what? Negation of this column. We have made this column, so negation of that. and the symbol for XNOR will be this P, this Q. That means you are taking this dot symbol and you are surrounding this by a circle. As I told you, exclusive NOR is just the negation of exclusive OR. So just take the negation of this column, we can get true, this will be false, this will be false, and this will be true. So you can see this column and this one, they are equivalent, they are same. So in another way, we can say biconditional operator, biconditional symbol, biconditional connective exactly same as the XNOR symbol or XNOR connective. So these are the basic of truth table. If you can remember this whole truth table, whatever I have done here, so if you get any kind of logical question, you can actually solve this by using only this truth table. तो इस truth table से तुम्हें सारा के सारे truth table का problem solve हो जाएगा. Just you have to remember the concept of this symbols or operators and what are output you are getting corresponding to this 4 set of inputs. So if you can remember, if you get any, that means any proposition, any expressions there, you can easily convert it into its, I mean you can easily get the output of that expression by using the truth table. Like one such question you can see here on the screen, you can see on the left side. So two expressions are there, S1 and S2. Question is, consider the following two formulas in the propositional logic. This one, which one is the correct? And here 4 options are given, and the options are given based on tautology, right? Now the question is, what is tautology? So in simplest way, we can consider a tautology means a expression which is always correct. So whatever the possibility of the input you are taking, as an output you will get always correct result, true result. Means if you make the truth table for that expression, all that output will be T or true. This kind of expressions are called tautology. Just opposite of that is called contradiction. Opposite means that all the outputs you are getting, whatever the irrespective of the inputs, that kind of expression are called the contradiction. And if you are getting tautology or contradiction, both mix, like here in the every truth table you can see all the result you are getting, they are having both true and false values as an output. So we can say they are all contingency. So here in this question, 2 expressions are given and they're asking that which one is a tautology we have to find here, right? That means if you can make the truth table for that, if any expression is giving you all the T output, we can say that expression is a tautology. Got it? Otherwise not. So this kind of thing we can get. Now the thing is, another way to check this also by using the equivalence laws. But if you are using equivalence laws, so you have to remember more than 10 or 15 actually formulas or laws to simplify an expression. And I think it will take more time than using the truth table to find whether these expressions are tautology or not. So my suggestion is that always use the concept of truth table to convert any expression, to check any expression is tautology or not. Okay, so let's solve this question, question number 7. So 2 expressions are given, like first expression is S1. It is given in this way. We have taken negation of P, conjunction, this is small p, proposition it has taken, then P disjunction Q, and the whole thing, this whole thing will be implies to the proposition Q there. So here you can see in the expression only 2 propositions P and Q are there. So to make the truth table, first make 2 columns for these 2 propositions P and Q. So as I told you, if you are taking 2 propositions, so you will find exactly 4 possibilities, 4 input set between them, and that can be written in a simple way like T, T, F, F, T, F, T, F. But my suggestion is this, since this kind of, we are actually doing this class for the aptitude test, so don't write this 3 and F, always use 1 and 0 because it will take less time to complete. So that's why my suggestion is that don't write this T and F in the aptitude test. So just use 10 formula, because 10 से बहुत कम टाइम में तुम लिख सकते हो 10 को. TF लिखने से यहाँ पे कहीं पे F के जगह पे F अगर T के जैसा दिख रहा है तो उसमें तुम ऑब्वियसली मतलब प्रॉब्लम हो जाएगा. तो इसीलिए 10 फॉर्म में लिखो ताकि तुम्हें बहुत इजीली बहुत जल्दी तुम्हें रिजल्ट मिल जाए. After that, you have to just check whether any negative symbol are there, negation symbols are there or not. You can see one negation P is there. So make one column for that proposition negation of P. You know what is negation P? Just opposite of the column P. There was TTFF, so we should take here FF and TT. So after that, we have to take a complex formula, complex actually expression. You can see this one P disjunction Q. So make one column for that, and already I have used the already I have given you the concept for this conjunction disjunction. That means when at least one of these propositions are true, then we can use the result as true. Like on the first, second, and third row, you can see at least one of P and Q are true. So here, first three row will give you the output as true. For the last one, since nothing is true there, only for that case result will be false. So after that, we have to combine these two columns by using this conjunction symbol. So you know what is the concept of conjunction. When both the things are happening together, both the things are true, as an output you can get the result as true. So I can write like negation P conjunction of P disjunction Q. So the basic concept of conjunction is same when. So now we have to take these two columns. So between them we have to find where both the columns are having true result. You can see only at the third row here you can see both the columns are having true result. So just put here true, and you can see first, second, third, nowhere you are getting that both the true result are coming. So that's why directly you can put here F, F, and F. Got it? Now what we have to do? We have to use this conditional connective from this expression to Q. Now if I name this expression as X, so actually we have to make the truth table for X implies Q, this one. Now what is the concept for this implication symbol? You know that when first expression is true but second is false, only for that case result should be false. So you have to first take the column for X and you have to search the column of Q. Now from there you have to just check that where the first one is true but second one is false. For that case we should write the result as false. Now if I take this X column first, so first result is F. So we should not take it. We should not actually consider anything. Just directly put here true, because false will come only for one case when the first okay, so actually we are having some internet issue, so that's why the problem occurs. So we can again start. So we are solving this problem. Two expressions are given. We have to just check which one is a tautology. And the first expression S1 we can find that is a tautology, because after finding the truth table for that expression, we are getting all result are true. That means whatever the possibility for the propositions we are having, always that expression is true. So that's why we can say the first expression S1 is a tautology. Now another expression S2 is there. Just we have to check whether this thing is tautology or not. But here actually you don't have to make another truth table. Everything is there. So we have to just take this conditional symbol conversely. Like here we have taken this X implies Q. Based on the question we can see now we have to find Q implies S. Sorry, Q implies X. So if we find this Q conditional X, so you know what to do. First of all, you have to take the column for Q and we have to just check that where T implies F is happening. If any such criteria condition you are getting, then directly you can put the result as false. For all other cases, result should be true. So we have to look for this condition that first proposition will be true, but second one is false. Only there we have to put result as false. Now here, if you look at the column Q, first one is true. So just we have to check whether our X is false or not. So yes, we can get that at the first row Q is true, but X is false. So T implies F, that will be F. So you don't have to complete your truth table because you can see that the first output you are getting as F. So if all the remaining, output are 3 also, the expression should not be a tautology, because if the expression is a tautology, all the output should be true. So that means what you can say, just a minute. Okay, so let's start once again. So I am leaving this problem for you because you can see we have found one expression is, oh sorry, second one I have also done. As I told you already, you don't have to complete this truth table because the first output you are getting here, that is false. That means this expression cannot be a tautology. So here the option should be S1 is a tautology but S2 is not. Option B will be correct. So you can see we have solved only one question in 40 minutes. So definitely it should not happen because for every question you will have maximum 1 minute time to complete. So you have to use any short trick, like you have to improve your calculation methodology or calculation speed to complete this tautology or this kind of truth table problem within 1 minute. I think that is possible. In place of this TF, if you put 10, and if you can neglect this negation P or any other negation expression, actually you can imagine this in your mind. Just you have to improve your speed of calculation. That's all. Now almost similar type of problem you can see here. This problem actually has came in the GATE exam 2021. So here also some expression is given. Just you have to check whether this expression is a tautology, contradiction or nothing. Basically contingency. So you know what to do. Similarly, make a truth table for that. If the output of this expression is having all the true result, you can say that expression is a tautology. If the output of the expression is having all the false result, just this should be a contradiction. If T and F, both the things are coming together, we can say that expression is a contingency, but that thing is not there. So I hope you can do that. But here another thing you have to consider, that here in place of two propositions, three propositions you are getting. And between three propositions there should be total 8 different combination of true and false values. I mean, as an input we can get total 8 combinations. So the best way to write this 8 combinations, that will be in this way. Suppose that is my proposition P, this is Q, and that is R. So best way to take the input there in this way. For the first expression, first proposition, take 4 T's. So T, 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 and T, and 4 F's. So take half of total 8 actually combination you will get. Take half T and half false. After that, in the next proposition Q, take 2 T and 2 false. So T, T, and F, F, and repeat the thing again. So once again I can write like in this way, TT and FA. And for the last proposition, take true and false values alternatively. They said there should be TF, 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 TF. So this kind of possibility you have to consider. As I told you, in place of T and F, you can use 1 0 also. Just a minute. Okay, I have allowed every participant, total 28 I can see. So I think no one is in the lobby. I have admitted everyone. Okay. So I think you can actually complete, you can do every problem from this truth table portion. I hope you have already studied this thing. So once again, just I am trying to remember you that these are the basic criteria, basic actually properties of truth tables. And for different symbols, different connectives, how the outputs are coming. So I have just discussed that thing. Okay, so you can just take the note of these kind of things, like these truth table formulas, these conditional laws, this biconditional law, or exclusive or exclusive not. You know this kind of thing in logic design also. You have done this kind of things, right? Now, like another thing you can see here, one problem like this, that suppose this and this symbol are denoting the exclusive or and exclusive nor, whatever we have discussed already. Question is, which one of the following is not correct, right? First one is given as P or Q, and the negation of all the whole thing is same as P nor Q. So just let me check here. P or Q is this one, this column. If I take the negation of that, we are getting exactly this column. So that means this expression is correct. I mean, first option is correct, but in the question we have to find which expression is not correct. Take the second one, that is negation P or Q is same as P nor Q. I think that will be false, because here for P and Q we are getting that negation of whole P or Q. This is same as P nor Q. So I think it should not be same. If you want, you can make a truth table for that and you can check it by yourself. Like if I make two columns for the propositions P and Q there, and if I take all four possibilities between them, like true, true, false, false, and true, false, true, false, and if I make a column for negation P also, because I need that one, so negation P will have false, false, And if I take the XOR between these two columns, negation P and Q, that thing we have to find in the option B. So what is the concept of XOR? That when exactly one is correct, result will be correct. I mean output will be true. So if I want to make the truth table for this expression P negation P XOR of Q, so we have to find that where exactly one correct option we are getting between these two columns. So you can see for the first row, one is true, one is false. Exactly one is true, so result should be true. Next is both are false, so result should be definitely false. Next one is both are true also, for that also result should be false. And for the last one, we are getting one is true, one is false. So definitely that thing is true. And I think it is exactly same as, yeah, not. Okay, so that means we are getting negation of P XOR Q, that is exactly same as P nor Q. I mean, option B is also correct. That is not false actually. I have taken that mistake and I have made that mistake, so that you don't make that mistake. Always complete the whole truth table. Only then you can check. Next one is negation P XOR negation Q. So negation P column is there, so make another column for negation Q, and you can see that Q is having the options like TF, TF. So negation will be FT and FT. So now for the third option, we have to take the XOR between negation P and negation Q. So between these two columns, we have to take the XOR. The concept of XOR is when exactly one is correct, result should be correct, right? But for the first row, you can see both are false, so result should be false. We are making the truth table for this one. Okay. For the second actually option, you can get first one is false, second one is true. So definitely result should be true because exactly one is true. For the third row, this is true, this is false. Exactly one is true, the result is also true. For the last row, both are having the input as true. So we can take this should be false. And you can see this column, this result you can see you have already done, you have got whenever you are making the truth table for exclusive OR. यहाँ पे देख लो exclusive OR का truth table में same output है FTTF. Here also you are getting FTTF. So option C is also correct. So since the first three options are correct, you don't have to go for the last option. You don't have to actually make the truth table for the last option. You can directly write the answer. You can choose the option that this is not correct. So in this way, I hope that if you get any questions related to the truth table, definitely you can make it. Okay. That's okay. That's now let me check whether any other questions you are getting or not. No. So this kind of questions are not there in the previous GATE exams. Now, one of the most important thing we are going to discuss, that is this question number 21. So I hope that at least in one aptitude test for one actually company, definitely you will get these kind of questions. So that's why my suggestion is that follow the procedure whatever I am trying to say you, and you can make a note of that. So it will help you sometimes definitely when you will get these kind of questions and you have to solve that. So here you can see the numbers you are getting, that is like less numbers like 3 and 5, this kind of things are getting. Now in place of 3, if I give you 315 or 320, in place of 51, I suppose I am getting 510. So for that kind of huge number, your calculator cannot give you the proper result. So there, how can we get this kind of result from there without using any calculator? How can we do that? Okay. So first of all, we have to learn about this thing. What is the concept of modulo? So modulo means if we divide this power 3 to the power 51, this number, by 5, what is the remainder? And I think in the coding you have used this percentage symbol, this modulo symbol, to find this one. So actually in coding we can consider 3 to the power 51, this percentile of 5. So we have to find this number. So that means question is this: if we divide this 3 to the power 51 by 5, what is the remainder we can get? Got it? So question is, without using calculator, or even if you use calculator also, you cannot solve this because calculator cannot compute 3 to the power 51. It's a very huge number. तो ऐसा कुछ करना पड़ेगा ताकि ये सब जो प्रॉब्लम है बहुत आसानी से हो सकता है. सो ये प्रॉब्लम जो यहाँ पे एक लाइन पे आया है, ये प्रॉब्लम ऐसे तरीके से भी आ सकता है. ऐसा पूछेगा, व्हाट इज द रिमाइंडर, व्हाट इज द रिमाइंडर, what is the remainder when we divide 3 to the power 51 by 5. तो इस नंबर को अगर 5 से डिवाइड करेंगे तो कितना रिमाइंडर मिलेगा, ये बताओ. सिमिलरली ऐसे भी क्वेश्चन आ सकता है, कोई भी ऐसा पावर का नंबर दे देगा, बोलेगा व्हाट इज द यूनिट डिजिट और लास्ट डिजिट ऑफ दैट नंबर. सो ऑल द प्रॉब्लम विल हैव सेम प्रोसीजर. अब बात है कि प्रोसीजर क्या है. So that procedure has a proper name, particular name, that is called the power modulo m. So for this kind of thing, first of all, what we have to do, that we have to break this power. We have to break this power as the summation of two powers. Like यहाँ पे 3 to the power 51 है, तो 51 को पहले 2 के पावर के समेशन में ब्रेक करना है. And how can you break that? So definitely you are taking all the summation symbols. So that means ऐसा कुछ लिखना है, ऐसा कुछ नंबर लेना है जिस सबको ऐड करके 51 मिले, एंड वहां पे जो सब नंबर आएगा सब 2 का कोई ना कोई पावर होगा. सो हाउ दिस इज पॉसिबल? वी हैव टू फाइंड द 2 पावर नंबर्स नियरेस्ट टू दिस नंबर. व्हाट एवर द पावर विल बी गिवन, तो देखना पड़ेगा उससे नियरेस्ट 2 के कौन सा पावर है. सो 51 है, 51 का नियरेस्ट कौन सा पावर होगा 2 का? एक तो हो जाएगा 64 और एक हो जाएगा 32. अब 64 लेने से तो 51 से ज्यादा हो रहा है, यू कैन नॉट टेक दैट. सो टेक द नंबर 32. If I take 32 from 51, the remaining number should be 19. Now you can see 32 is some power of 2, but 19 is not. So what you should do, you have to again convert this 19 in terms of the power of 2. So I can write in this way, there should be 32, nearest 2 powers of 19 will be 16, क्योंकि 19 के बाद आएगा 32, उससे पहले है 16. So definitely we should take here 16. The remainder extra we are getting, that should be 3. So now you can see 32 and 60, these two are some power of 2, but 3 is not. So we have to find a number which is a 2 power nearest to 3, and that number is 2 itself. So I can write this as 32 plus 16 plus 2, and extra should be 1. And you know that 1 is also a power of 2 because 2 power 0 is 1. So I have written this 51, this power, as the summation of power of 2. So we are getting one such expression. Now we have to start with one line. That line is this, that 3 will be congruent to 3 modulo 5. So we have to find 3 to the power 51 modulo 5, right? We have to always start with this number. जो भी वहाँ पे दिया रहेगा, लाइक ऐसा दिया होगा 7 to the power 51 का रिमाइंडर निकालो जब उसको 13 से डिवाइड करेंगे. तो विल स्टार्ट ऑलवेज 7 इक्वल कॉन्ग्रुएंट टू 7 मॉड्यूलो दैट नंबर, जिस नंबर से डिवाइड करने जा रहे हो, क्योंकि ऑलवेज कोई भी नंबर उस नंबर के खुद का कॉन्ग्रुएंट होगा. बिकॉज कॉन्ग्रुएंट का कॉन्सेप्ट क्या है कि इन दोनों को अगर सब्ट्रैक्ट करोगे वो इस नंबर से डिविजिबल होगा. तो इसलिए 3 माइनस 3 कितना? 0. 0 को 5 डिवाइड कर सकता है. सो दैट मीन्स एनी नंबर विल बी कॉन्ग्रुएंट टू इटसेल्फ विद रिस्पेक्ट टू एनी मॉड्यूलो. तो स्टार्ट विथ दिस लाइन ऑलवेज. यहाँ पे 3 है इसलिए 3 इज कॉन्ग्रुएंट टू 3 लिखा. अगर 7 टू द पावर कुछ नंबर होता या फिर और कुछ नंबर टू द पावर नंबर होता, वही लिखते हैं यहाँ पे, दैट नंबर इज कॉन्ग्रुएंट टू दैट नंबर इटसेल्फ, मॉड्यूलो ऑफ दैट नंबर. एंड आफ्टर दैट यू हैव टू टेक द पावर एवरी टाइम. ये जो इक्वेशन है, इक्वेशन का हर बार स्क्वायर करते जाओ. नाउ इफ आई टेक द स्क्वायर ऑफ दैट, तो ए हो जाएगा तुम्हारा 3 स्क्वायर एंड दैट शुड बी 3 स्क्वायर. यहाँ पे 3 स्क्वायर हो जाएगा, दैट इज 9, राइट? सो 9 mod of 5. सो इस साइड का जो पावर है उसको जैसा था वैसे ही रखने दो. 3 to the power जो भी होगा पावर ही रखो. यहाँ पे नंबर को चेंज करो. So at this stage we are getting 9 modulo 5. What is that this mean by 9 modulo 5 के 9 को जो 5 से डिवाइड करेंगे तो रिमाइंडर कितना होगा? तो डेफिनेटली 9 को 5 से डिवाइड करेंगे तो उसका कोसेंट जो है 1 होगा, एक्स्ट्रा 4 बचेगा. सो आई कैन से दैट शुड बी 4 modulo 5. ओके, इन द नेक्स्ट स्टेप अगेन टेक द स्क्वायर. अब फिर से दोबारा दोनों साइड से स्क्वायर करो. सो 3 का स्क्वायर कितना होगा? 3 to the power 4. So 3 to the power 4 will be here 4 square. 4 square means what? 16. So 16 modulo 5. So 16 modulo 5 means if we divide 16 by 5, so what is the remainder? That should be 1. So I can write that should be 1 modulo 5. क्योंकि 16 को 5 से डिवाइड करोगे तो 15 तक होगा और एक्स्ट्रा एक ही रह जाएगा. So that's why I should take 1 modulo 5. Got it? Now again take the square both sides. So 3 to the power 4 का अगर स्क्वायर करेंगे so 3 to the power 8 मिलेगा. So 3 to the power 8 will be congruent to 1 square is 1. So always इस साइड में 1 ही रहेगा तो तुम्हारा कैलकुलेशन जो है वो सिंपल हो गया. इसके बाद जो भी पावर लोगे everything will be 1, right? Similarly again अगर उसका दोनों साइड स्क्वायर करेंगे 3 to the power 8 square basically this will be 3 to the power 16 and there 1 square that is also 1 again. So 1 mod of 5. Again take the square, we are getting 3 to the power 32, that should be 1 mod 5. And we should stop here now because we have reached at the highest power what we need. तो 2 के जो highest power तक चाहिए था उतना तक हम लोग पहुंच गए हैं. So we should stop here now. After that remaining problem is very simple. What you have to do? What you have to find? We have to find actually 3 to the power 51 modulo 5. Now already we have broken this 51 in terms of this summation. So I can write this as 3 to the power 32 plus 16 plus 2 plus 1 and there will be mod of 5. Now you know that power of summation mean we can take power product. So that should be 3 to the power 32 into 3 to the power 16 into 3 to the power square 3 to the power 1 and there should be modulo 5. Now already we have calculated these values. Like first value we need, that is for 3 to the power 32 mod 5. That value is what? That value is 1. So I should put here 1. Then 3 to the power 16 mod 5, that is also 1 here we are getting. So there will be 1. Then 3 square. So 3 square is what? 4 modulo 5. So there should be 4. 3 to the power 1 here we are getting, that is congruent to 3 mod 5. So there should be 3 and there will be mod of 5. So we are getting here 12 mod of 5. Okay, so what does this mean? That the remainder when we divide 12 by 5, तो 12 को अगर 5 से डिवाइड करोगे तो कितना रिमाइंडर है? That is 2. So we should take here the result as true, 2. That means 3 to the power 51 को 5 से डिवाइड करोगे तो तुम्हें रिमाइंडर 2 ही मिलेगा. So you can see this 3 to the power 51 is a huge number. You can check that if you are using calculator. So calculator के में तुम अगर 3 to the power 51 डालोगे, that's a very huge number you can see. वो कैलकुलेटर में पूरा आएगा नहीं, वो 10 to the power सम फॉर्म में आएगा. तो उनमें से 5 से डिवाइड करके कितना रिमाइंडर होगा तुम फाइंड ही नहीं कर पाओगे. The best way is to use this algorithm, this procedure, that is called square modulo m. That is called square modulo m method. Okay, so every time in the congruent equation we are taking the squares. For whatever the power is given, we are writing that as a summation of 2 powers, right? And after that with a basic congruent equation, every time we are taking the square of the congruent equation both sides. I am keeping this one side fixed and in the another side I am converting those numbers with respect to the modulus what is given there. Got it? So if anyone is listening, just tell me that you are having any problem, any doubt, any question, or do you want to solve me another problem like this? Anyone listening? If anyone listening, please raise your hand. I've just checked that how many of you are there exactly. Please raise your hand if you are listening. Okay, good. I was expecting 3 or 4 people. I mean, that's too much. If with 7+ people is raising their hands, so it's too much. That means I was not expecting that actually. अच्छा कोई बात नहीं तुम तो कोई बताओ कि जो लास्ट प्रॉब्लम किया था उसमें कुछ भी डाउट है एनी डाउट एनी क्वेश्चन एनीथिंग otherwise I should solve or if you want I can solve another similar type of problem also. Should I solve any other problem? Okay. Okay, ठीक है. I think that no one will respond. So let me do it myself. So सेम टाइप ऑफ प्रॉब्लम डिफरेंट फॉर्म में आ सकता है. कैसे? जैसे कि ऐसे सपोज पूछ लिया व्हाट इज द यूनिट डिजिट, व्हाट इज द यूनिट डिजिट ऑफ 2 to the power 81, what is the unit digit of 2 to the power 81? मान लो यही वाला क्वेश्चन है. सो यूनिट डिजिट मीन्स व्हाट के किसी नंबर का जो पहला नंबर होगा मतलब किसी नंबर का फर्स्ट डिजिट होगा वही है यूनिट डिजिट. तो 2 to the power 81 दैट्स वेरी ह्यूज नंबर राइट. कैलकुलेटर हैंडल नहीं कर पाएगा. सो what algorithm we should use such that we can get the unit digit of this number, this huge number. Okay, so exactly same problem. Question is कोई नंबर का यूनिट डिजिट कैसे मिलेगा? डेफिनेटली उसको अगर 10 से डिवाइड करोगे तो जो रिमाइंडर होता है वही उसका एक्चुअली यूनिट डिजिट होता है. लाइक कोडिंग का ऐसा बहुत सारे प्रॉब्लम किए होंगे कि कोई भी नंबर n है, n का अगर एक डिजिट चाहिए मतलब यूनिट डिजिट, सो जस्ट यूज n percentile 10, right? n modulo 10. So same thing we are doing here. So if we have to find the unit digit of this number, so actually they are asking us to find 2 to the power 81 mod of 10. Okay, so चलो अभी सेम प्रोसीजर पे ए वाला प्रॉब्लम को सॉल्व करके देखते हैं. बट द क्वेश्चन इज दिस काइंड ऑफ प्रॉब्लम में टेक सम टाइम, बट यहाँ पे मैं समझा रहा हूँ इसलिए ज्यादा टाइम लग रहा है. सो इफ यू फॉलो द प्रोसीजर and if your calculation speed is nice, then definitely within 1 or 1.5 minutes you can complete this kind of problem, right? So let's check how we can solve this problem. So as I told you that whatever the power will be given, that should be written as a power summation of power of 2. So 81 को 2 के पावर के सामने लिखना है. Now 81 के नियरेस्ट 2 के पावर है, उससे कम है 64, उससे ज्यादा है 128. So definitely I should go for 64, right? तो 64 जाने से और कितना रहेगा? I think 17. हाँ 17 रहेगा. Now this 64 is a power of 2, 17 नहीं है. 17 मतलब क्या है? 16 plus 1. So I can write 64 plus 16 plus 1. Now we should start with a basic congruent equation, and every time we have to take the square both sides of the congruent equation. So since the number you are taking 2, so I should start with 2 is congruent to 2 mod 10. That is obvious because congruent का concept क्या है कि इन दोनों का subtraction always 10 से divisible है. तो देख लो 2 minus 2 is 0, that is divisible by 10. After that every time we have to take square both sides. तो दोनों साइड स्क्वायर करेंगे तो इस साइड आएगा 2 स्क्वायर एंड देयर इज 2 स्क्वायर इज 4. सो आई कैन राइट 4 mod 10. एंड 4 को अगर 10 से डिवाइड करोगे 4 ही रहेगा, कोई चेंज नहीं होगा. नाउ टेक द स्क्वायर अगेन. सो if I take the square here, 2 square of square basically 2 to the power 4 you will get, and here will be 16 modulo 10. So we are getting 16 modulo 10. That means if we divide 16 by 10, what is the remainder? That is 6. So I should write 6 mod of 10. Okay. Once again, take the square both sides. If I take the square, that will be 2 to the power 4 whole square. That will be 2 to the power 8. And here we are getting 6 square. That is 36 and mod of 10. Okay. And 36 mod of 10 means that is also again 6 mod of 10. So actually we have reached at a loop, क्योंकि इसके बाद जितना भी स्क्वायर करोगे जितना टाइम ऑलवेज ऐसे 6 आएगा, 6 का स्क्वायर करोगे तो 36 है, उसको 10 से डिवाइड करोगे तो सेम 6 मिल जाएगा। तो इसका इसलिए ये जो प्रॉब्लम है बहुत सिंपल हो गया है, क्योंकि उसके बाद जितना भी पावर होगा लाइक टू द पावर 16 भी लोगे वो भी 6 स्क्वायर 36 mod 10 मतलब 6, उसके बाद उसको दोबारा स्क्वायर करोगे उसमें भी 36 आएगा, उसका भी रिड्यूस करोगे 10 से तो वो भी 6 है। सो दैट मीन्स आफ्टर दिस 2 to the power 4 ऑल द वैल्यूज आर 6 विद रिस्पेक्ट टू mod 10। तो तुम चाहो तो और कैलकुलेशन करने का जरूरत नहीं है, क्यों जाओगे, क्योंकि पता है उसके बाद का 2 का सारा पावर 6 आएगा विद रिस्पेक्ट टू mod 10। तो डायरेक्टली तुम प्रॉब्लम पे आ जाओ। सो वी हैव टू एक्चुअली कैलकुलेट 2 to the power 81 mod of 10, and 81 can be written as 2 to the power 64, 2 to the power 16 and 2 to the power 1. That should be with respect to mod of 10. So we have already seen 2 to the power 64, 8 के बाद जितना भी पावर है सब 6 है, 2 to the power 16 उसके लिए भी 6 है, and 2 to the power 1 that is 2. So 6 into 6 into 2 mod of 10. So we are getting here 36 into 2, 36 into 2 is 72. So we are getting here 72 mod of 10. तो 72 को अगर 10 से डिवाइड करेंगे, what is the remainder? That number we need and that number will be 2. तो इसका भी 2 to the power 81 का unit digit 2 होगा. You can check it. Got it? So if you can use any other simpler approach, simpler method, that will be okay. Now another method is there. I think this is called the Fermat's formula, but उसके लिए जो मॉड्यूलो का जो वैल्यू होगा that should be a prime number, उसको प्राइम होना चाहिए। so that thing is not applicable for this। तो इसीलिए जो स्क्वायर मॉड्यूलो एम है, यहाँ पे जो भी पावर ले रहे हो, जो भी तुम मॉड्यूलो ले रहे हो, डज नॉट मैटर, कोई भी नंबर दो, उस नंबर को रिड्यूस करना अगर है किसी नंबर के रिस्पेक्ट में, you can use this procedure, this method to do that. Got it? So I hope you can solve this kind of problem. Similarly, if the question is like this, what is the last 2 digits of a number like 120, or I can write in this way, suppose एक number लिया मैंने 17. Okay, so question is what is the last 2 digit of 17 to the power, suppose I am taking 92. So इस नंबर का अगर लास्ट 2 डिजिट चाहिए, तो कोई भी नंबर का लास्ट 2 डिजिट कैसे मिलेगा? इफ वी डिवाइड दिस बाय 100. सो एक्चुअली दे आर आस्किंग फॉर दिस थिंग, व्हाट इज द वैल्यू ऑफ 70 to the power 92 mod of 100, this thing. Now I have already given you the procedure. First of all, break this power in terms of the summation of 2 powers. Start with the basic congruence equation. In this case 70 will be congruent to 70 mod 100. Every time take square both sides, and after that break this power summation as the product term, and whatever the congruent value you are getting with respect to mod of that, just put them, product them, take the product of them, calculate them, and just you can use the calculator to do that. So ये सारा प्रॉब्लम इस तरीके से पॉसिबल हो सकता है, राइट? तो यहाँ पे 2 चीज आज बताया, एक है ट्रूथ टेबल वाला कॉन्सेप्ट, एक है ये पावर मॉड्यूलो एम वाला जो कॉन्सेप्ट है ए वाला। तो ये चीज बाद में बहुत तुम्हें काम में आएगा, देखना कोई ना कोई एप्टीट्यूड टेस्ट में इस टाइप का प्रॉब्लम तुम्हें जरूर मिलेगा। ओके, सो लेट मी चेक वेदर एनी अदर क्वेश्चंस आर देयर और नॉट। सो yeah, this kind of problem is also there. So question is, which one of the following is a closed form expression for the generating function of a sequence this? तो इनमें से कौन सा इस वाला सीक्वेंस का जनरेटिंग फंक्शन है? नाउ द जनरेटिंग फंक्शन ऑफ सीक्वेंस वो क्या होता है? generating function of sequence, basically we have to form a series जहां से इस sequence का तुम्हें term मिल रहा है. So actually they are asking for this thing, summation. Basically f(x) एक function होगा that is same as summation an x to the power n. So where an is given, so they are asking for this function f of x. तो जो generating function of sequence है, that is like this form, that is actually power series formula you can consider an x to the power n, where an thing is given. तो क्वेश्चन है इनमें से कौन सा फंक्शन का जेनेटिक सीक्वेंस an है, जहाँ पे an का वैल्यू है 2n plus 3. So just let me check. So we have to find f of x, which is the summation, okay, which is the summation n equal to 0 to infinity, actually जितना मतलब जा सकता है an x to the power n, where an value is given in this way, n equal to 0 to infinity, an value is 2n plus 3. So write here 2n plus 3 and there will be x to the power n. Got it? Now just break this summation. तो इसको दो तरीके से दो पार्ट में ब्रेक कर दो. एक हो जाएगा n equal to 0 to infinity 2n x to the power n, 2n x to the power n, और एक हो जाएगा summation n equal to 0 to infinity 3 into x to the power n, 3x to the power n. ओके, सो बस यहाँ से स्टार्ट करना. जेनेरेटिंग फंक्शन जो होता है सीक्वेंस का होगा f(x) equal to an x to the power n, or the sequence is given in this way. So after that, you know that there are 2 and 3, these are the constant values. You can take that out of the summation. So 2 times n equal to 0 to infinity n x to the power n, and there similarly I can take these 3 out. This will be summation 0 to infinity x to the power n. Got it? Now my suggestion is this, that break this summation into the expression of x, जहाँ पे n का वैल्यू 0 से स्टार्ट हो रहा है. So I can write in this way 2 into when n equal to 0, that will be 0 into x to the power 0, that is 0. Then there will be for n equal to 1, 1 into x to the power 1. So basically we are getting x. For n equal to 2, 2 into x square. So 2x square we are getting. उसके बाद जब n का वैल्यू 3 होगा, we should get 3x to the power cube, basically 3x cube plus 4x to the power 4, like this. An infinite series we are getting from here, and plus here we are getting 3 times of when n equal to 0, that is 0 to the power 0, that is 0, plus when n is 1, oh sorry, when n is 0, x to the power 0, that is 1. I have made that mistake. That should be 1, x to the power 0, 1, plus for n equal to 1, x power 1, that is x. When n is 2, that should be x square. Similarly, x cube up to x to the power infinity. This kind of thing we are getting. Got it? Now here we are getting one expression like this: x plus 2x square plus 3x cube plus 4x4. Question is, can we find a proper form such that basically proper series of expression which expansion looks like somehow in this way? तो ऐसा कुछ सीरीज या फिर ऐसा कुछ समेशन फॉर्मूला है जिसका एक्सपेंशन ऐसा है, बट एग्जैक्टली ऐसा नहीं है. इसके जैसा सिमिलर एक फॉर्मूला है. व्हाट इज दैट फॉर्मूला? इफ आई हैव ऑन एक्सप्रेशन लाइक 1 plus 2x plus 3x square plus 4x to the power cube, 4x cube, then we have one formula. So for that what should we do? I can take x common from the whole expression. तो पूरा से अगर x common ले लेंगे, so we can get this thing 2 times x. तो इसमें से x चला जाएगा हर एक टर्म में, सो तो पहले 1 होगा, 0 को तो हटा दो, यहाँ से मिलेगा 1, 2x 3x स्क्वायर, x क्यूब, चलिए उसके बाद होगा 5x to the power 4, 6x to the power 5, ऐसा है. and there we are getting 3 times 1 plus x square x to the cube, like this. So this expression has a proper form, particular form. What is the form? That is 1 minus x to the power minus 1, or we can say that is 1 by 1 minus x. Okay, वो 1 minus 1 by 1 minus x का एक्सपेंशन है, ए वाला समेशन फॉर्मूला. ओके, दिस वन. अब देखते हैं इसके लिए क्या है. So this is having the formula as 1 minus x to the power 2. Basically minus 2 उसके फॉर्मूला है. So I can write 1 by 1 minus x square. Actually you can see that we can get this expression by taking the square of this one, taking the derivative of this one. तुम देख लो, a वाला एक्सप्रेशन को अगर डेरिवेटिव करेंगे तो हमें a वाला एक्सप्रेशन तुम्हें मिलेगा. ओके, तो देख सकते हो जैसे कि 1 का डेरिवेटिव 0, देखो 0 था, मतलब 0 इस पे है मान लो शुरू में. फिर x का डेरिवेटिव 1, दैट इज देयर. x स्क्वायर का डेरिवेटिव 2x, x क्यूब का डेरिवेटिव 3x स्क्वायर, x टू द पावर 4 का डेरिवेटिव 4x क्यूब. So basically this expression is the derivative of this expression. Now what is the derivative of 1 by 1 minus x? That is 1 by 1 minus x square, this one. तो इसीलिए ये वाला जो एक्सप्रेशन है ये एक्चुअली 1 by 1 minus x square का उसका एक्सप्रेशन है. Now just simplify this. So this is 3 by 1 minus x. So I can take 1 minus x square as the denominator. So here we can get 2x, and here I can get 3 into 1 minus x, basically 3 minus 3x. So the final expression we can get, that should be 3 minus x divided by 1 minus x whole square. Got it? So our goal is not to solve this problem, but whatever expressions, whatever summation formula we have got, you should remember those formula. So if anyone have not written anything from here, I should suggest that you should write those expressions what I am writing now. So you can make a box or anything and write the expansion for this kind of expression. Like first one I can get 1 minus x to the power minus 1, or in another way we can say that will be 1 by 1 minus x. Now इसका expression क्या है? So this will be like 1 plus x square plus x cube, like this. If I take 1 plus x to the power minus 1, basically that is what? 1 by 1 plus x. Here everything will be same, but you should take plus and minus symbols alternatively. So that should be 1 minus x square minus x cube x to the power 4, like this. And you know that already I have shown you that if I take the derivative of them, so you will get some terms definitely. And one thing we have used here, that is 1 minus x to the power minus 2, or we can say that will be 1 by 1 minus x whole square. That will be that is what? That is 1 that is 1 plus 2x plus 3x square plus 4x cube, like this. Okay, अच्छा. Then if I find the expression for e to the power x, that should be 1 plus x by factorial 1, x square by factorial 3. Okay, take minus x there. Here also the symbol will come plus and minus alternatively. So this kind of expression or this kind of formula you should remember. It can help you sometimes when one infinite expression will be given. We should simplify it into a simple form, simple actual formation, simple formula in this way. Got it? So 3 things we have learned today. One is this power modulo m thing. One is the tautology contradiction, this kind of, that means truth table thing. And another is this one, that how can we convert any expression infinite series into simplest form. And for that, you should remember that one also. What is the generating function of a sequence? Basically, the function we are getting, that should be an infinite series a n x to the power value is given in this way. Got it? Achha. Now another thing you can get, that is the quantifier things. So I should write few formulas for the quantifiers, and you can take the note of that. Now I hope you know what are the quantifiers. Quantifiers are what? That suppose you have some propositions, and that propositions are the variables in it. So what should we do? That we have to check. We have to check that these propositions are true for how many value of that variable x there. If that proposition is true for every variable, every possible x, we should use one quantifier, that is called the universal quantifier. The symbol is this. The symbol is only this one, and whatever the variable you are using, you have to just write the name of the variable. Like I can write x or y or z like this. And if any propositions based on any variable there is true for few value of that variables, we should use one quantifier which is called the existential quantifier, and it looks like this. And formula will be same, the expression will be same. After this symbol, you should put the name of the variable like x or y or z like this. Got it? So these kind of things you already know. So here I am not actually teaching discrete mathematics. I am just trying to remind you that these kind of things you have done already in the class in the first sem, and it may, you need these kind of things again when you will go for the aptitude test for the placement actually. Now you should write few rules based on the quantifiers. Quantifier का कैसे rule है? Like one such rule you can find that the universal quantifier will be distributive over conjunction. That means if I take two propositions like p of x and q of x, so between these two propositions I have taken conjunction. You know the meaning of conjunction? That means these two things are happening together, and this is happening for every x. If this thing is happening, this is exactly same as the individual things are happening and simultaneously also. So I can write for all x px conjunction for all x qx also. That means we can say that the universal quantifier is distributive over conjunction. मतलब दोनों ऐसे एक्सप्रेशन होगा, दोनों सेम वेरिएबल के लिए है, तो उसके बाहर अगर फॉर ऑल एक्स रहेगा, लेकिन दोनों अगर फॉर ऑल एक्स सब एक्स के लिए ट्रू हो रहा है, तो दोनों ही इंडिविजुअली ट्रू होगा सारे के सारे एक्स के लिए. Got it? But the existential quantifier, so definitely this thing will definitely work. कि सबके लिए अगर हो रहा है तो कुछ चीजों के लिए तो होगा ही होगा. जहाँ पे सब लोगों के लिए कुछ कंडीशन होता है, तो उनमें से जितना भी लोग ले लो सबके लिए हो रहा है. तो मान लो 100 लोगों का कोई गैदरिंग है, तो उनमें सब लोगों के लिए कुछ पर्टिकुलर क्राइटेरिया है, तो उनमें से कोई भी 2-3 लोगों को चूज कर लो, उनके लिए भी सेम क्राइटेरिया रहेगा. दैट मीन्स दिस थिंग विल हैपन फॉर एक्जिस्टेंशियल क्वांटिफायर ऑल्सो. जहाँ पे जो चीज फॉर ऑल के लिए होगा, डेफिनेटली कुछ लोगों के लिए तो होगा ही होगा. सो सेम थिंग कैन हैपन फॉर the existential quantifier. That's the obvious thing. You don't have to write this thing. This is obvious कि जहाँ पे सबके लिए होता है कुछ, तो कुछ के लिए तो होगा ही definitely, right? So I can write this thing, okay? But for the existential quantifier, you should remember that one, that if you have taken two propositions, they are connected by the disjunction, then this existential quantifier can be distributive over this disjunction. We can write there exists x px, disjunction there exists x qx. So this thing cannot happen for all x, क्योंकि कुछ लोगों के पास a है या फिर a है, मतलब कुछ लोगों के पास a है, कुछ लोगों के पास a है, right? So that means what we are getting, that universal quantifier is distributive over conjunction and existential quantifier is distributive over disjunction. और जो भी प्रॉपर्टी यूनिवर्सल मतलब क्वांटिफायर के लिए होगा तो डेफिनेटली वो तो एग्जिस्टेंशियल के लिए होगा ही होगा. सो दिस सेकंड क्राइटेरिया, सेकंड लाइन ऑफ व्हाट एवर आई हैव रिटन, दैट थिंग इज अ ऑब्वियस लाइन, राइट? ये तुम ना भी लिख सकते हो. बट फ्रॉम देयर मेनली व्हाट शुड वी consider, that is the formula that is on rule law, which is called the negative quantifier law, which is called the negative quantifier law. So I'll show you where you should use this kind of things. वो मैं दिखाऊंगा तुम्हें, अभी कुछ एग्जांपल लेके मैं दिखाऊंगा कैसे करके ये सब चीज कौन सा एप्टीट्यूड क्वेश्चन के लिए एप्लीकेबल होगा. And I think 2 classes are very less because we have a set of MCQ questions from discrete mathematics, and this kind of question you'll get in your aptitude test. But we have very less much of time, so we don't have to go through all the questions. तो चलो, नेगेटिव क्वांटिफायर लॉ क्या है? That 2 laws are there. One is for universal quantifier, one is for existential. So if I take negation outside of a universal quantifier, this is exactly same as the existential quantifier negation of that expression. That means if you want to put a negation inside of an expression where that expression is having universal quantifier, so the symbol you should change before you enter the negation inside the expression. And exactly same thing will happen for the existential quantifier also. Like if I write negation of there exists x px, this will be same as for all x negation of px. The converse is also true. Suppose this thing is happening, for all x negation px thing is coming, so you should take this negation out, then you should change this for all x to there exists x, right? This thing you should change. So from there mainly these 3 things you should learn. एक है ये वाला, ये दोनों है, और एक नेगेटिव क्वांटिफायर लॉ है. गॉट इट? अब देखते हैं कि किस टाइप का क्वेश्चन यहाँ पे आया है. लाइक द फर्स्ट क्वेश्चन, वन एक्सप्रेशन इज गिवन, सो दे आर आस्किंग दैट व्हिच वन इज नॉट लॉजिकली वैलिड. इनमें से बेसिकली कुछ इक्विवेलेंस स्टेटमेंट्स दिया है, इसके साथ ए इक्विवेलेंट है, इसके साथ ए इक्विवेलेंट है, ऐसा कुछ इक्विवेलेंट स्टेटमेंट दिया है. बस तुम्हें देखना है इनमें से कौन सा इक्विवेलेंट स्टेटमेंट करेक्ट नहीं है. सो वी हैव ऑलरेडी द फॉर्मूला व्हाट वी नीड, सबके सब है. अभी चेक करते हैं कि कैसे करके इनमें से कौन सा एक्सप्रेशन सही है, कौन सा गलत है. फॉर द फर्स्ट वन, फॉर द फर्स्ट एक्सप्रेशन यू कैन सी दैट वी आर गेटिंग द एक्सप्रेशन लाइक दिस for all x. नंबर ए जो ऑप्शन है वो दिया है for all x px disjunction of some argument or of some proposition w there. So between these 2 proposition we are getting one disjunction, but here I have not written anything for the universal quantifier. अभी disjunction के लिए universal quantifier है, ऐसा कोई रूल लिखा नहीं. But still we are getting this expression is equivalent to something. Question is, can we distribute this thing over these 2 proposition? Yes. Why? Because here this proposition w is irrespective of any variable. तो यहाँ पे देख सकते हो जो w है, w किसी वेरिएबल के ऊपर डिपेंड नहीं कर रहा है. तो w अगर वेरिएबल के लिए डिपेंड नहीं करेगा तो for all x जो है, this for all x is applicable only for this proposition who is having this variable x there. तो for all x बस उसी proposition के लिए काम करेगा जिसमें वो वाला वेरिएबल x है. w के पास तो है नहीं, w is a proposition without any variable there. So that's why here this for all x will be applicable only for the proposition px. So what should we write? We can actually write this as for all x px, and there should be disjunction, and we can write another proposition w there. That thing is correct, but हमें जो correct नहीं है वो वाला चाहिए. So let us check what is the second option. So second option we are getting in this way. There exists x, px, conjunction, then w. Same thing we are getting here. That is, we have got that two propositions are there. One proposition is depending on a variable x, other is not. So definitely whatever quantifier symbol you have used, this quantifier will be applicable over that proposition only, and all the remaining thing will be same, that will be unchanged. So we can write this is exactly same as there exists x px, conjunction w, this one. Number C, if I take this expression for all x, px implies w. But whatever the formulas we have written here, you can see there is no conditional symbol over there. Either we have taken negation, or we have taken conjunction or disjunction. So as I told you, three basic symbols, three basic operators are these three: conjunction, disjunction, negation. So whatever connectives or whatever symbol, whatever operator you will get without these three, or which is not these three, definitely the rules will not be applicable. So better if we convert those operators, convert those symbols into the usual form, like the form which will have only conjunction, disjunction and negation, then only we can use all the equivalence laws. तो यहाँ पे भी imply के लिए कुछ भी law यहाँ पे लिखा नहीं है. So what should we do? We should first convert this whole expression without this imply or without this conditional connective. How can we change that? Already at the beginning of today's class, I have written one law. By using that law, we can convert any conditional statement into a statement where only negation and disjunction will come. So here exactly same law I can apply. So I can write this as, I can write for all x out. There should be this implies of that means negation of first one, negation of px, and there should be disjunction and w. This one. Now, as I told you, here two propositions are there, but among them only this one is having the variable x there. So that means the quantifier you are using, that quantifier is only for this proposition. So I can merge them. I can get the expression like for all x, negation of px, and there should be disjunction of w will be there, because w is not depending with any variable x there. So this for all x will not be applicable over there. After that, what I want to do, that suppose I want to take this negation outside. So for that, recently I have written some law, negative quantifier law, this one, that for all x negation px, if I want to take this negation out, this universal quantifier will be converted into the existential quantifier. So I can write in this way, negation of there exists x px, disjunction w. So basically we are getting some form like negation of p, disjunction q, and that is for which form? This is for this implies of that. So we can simplify this as there exists x px implies of w. Basically I have used here the conditional law, reverse conditional law. p implies q होने से तुम्हें पता है वो negation p disjunction q होता है. तो यहाँ पे देखो negation of something disjunction a है. So we can write this one implies that. But here in the option C, we can see that on the right hand side, the expression it is having for all x px implies w. That is not same as this one. That means the option C is given, option C expression is given, that is actually wrong expression. तो यहाँ पे C जो है, C is not logically valid. दिखा सकता हूँ यहाँ पे for all होना चाहिए था, there exist होना चाहिए था, यहाँ पे for all मिल रहा है. If you check the next option, you can see that's the correct option. उसको तुम सिमिलर मैनर पे कन्वर्ट करते जाना. There exists text. First of all, convert this conditional statement, conditional connective, into a statement, into a expression which will have only negation and disjunction. After that, since between these two propositions, only one is having the variable x, so and this quantifier will be applicable over this proposition only. W is without any variable, so keep that aside. After that, negation value, whatever you are getting, take that out. So there exists will be converted to for all x. So somehow you will get some expression like negation of for all x px disjunction w, and it will be exactly same as for all x px w implies w. So option C is not a correct option. All the remaining options are same. The remaining options are correct. Okay. So hope you are listening. Few of you are definitely listening. So now let me check whether any other question we can find like this. Acha, this is the question from logical inferences. This kind of question definitely you will get. Some statement will be given, some conclusion will be given. Just you have to check that whether those conclusion are fulfilling every statement given or not, right? तो ये बाद में करेंगे. अभी क्वांटिफायर पढ़ रहे हैं तो चलो क्वांटिफायर का प्रॉब्लम जो है सॉल्व करते हैं. Like one question is given in this way, that for the statement some real numbers are rational. It's given that question is this, that some real numbers are rational. Some real numbers are rational. इसको logically convert करना है, right? So how can I convert this statement some real numbers are rational into the logical form? So basically देखते हैं कि इसका लॉजिकल फॉर्म क्या होगा. तो फर्स्ट ऑफ ऑल एक मिनट, हाँ I hope you can see it now. अच्छा दिख रहा होगा शायद. Okay, just random. First of all, in this statement, you can get the term like sum, right? So sum means what? That whatever thing is happening, this is not for all. So that means the logical form cannot get the universal quantifier. तो फर्स्ट ऑफ ऑल उसमें यूनिवर्सल क्वांटिफायर नहीं होना चाहिए. तो यूनिवर्सल क्वांटिफायर कहाँ पे है? बी ऑप्शन तो होगा ही नहीं. So only you have the options like A, C and D. Another thing you should learn from here that the existential quantifier cannot have the implied symbol. तो कोई भी existential quantifier में implied symbol नहीं हो सकता है. Like you cannot write like there exists x, px implies qx. Why? Because the meaning of this is when px will be true, when px will happen, then qx will happen, then this is true. But if you look at the truth table for the implies or the conditional connective, you can see when both are false also, result is true. So that means this thing will be true when even p and q both are false also. But this quantifier concept is coming in this sense that for how many value of that variable there, the whole statement is true. So that's why the thing you are taking, this is self contradictory statement. तो इसीलिए देयर एग्जिस्ट में कभी इम्प्लाई सिंबल जो है कंडीशनल कनेक्टिव जो है इट कैन नॉट कम. तो इसीलिए ऑप्शन डी जो है वो गया. तो बी और डी गया, ओनली ए और सी मिलेगा. दोबारा सुनो कि क्यों एक्चुअली ये नहीं हो सकता है. बिकॉज इफ यू लुक एट द ट्रूथ टेबल फॉर कंडीशनल कनेक्टिव, you can see here when both p and q are false, this one here result is true. So that means p implies q will be true even both p and q are false. But here what that is mean by quantifiers, that for how many values of that variable those whole statement is correct, right? So here the whole statement is correct for when this px and qx both are false also. So you cannot take implies for there exists x actually, this one. So what should we get? That we have to now check only the option A and option C. So option जो A है, this is having in this way this sense that there exists x, real x or a rational x. Now if this is the expression, if I break this expression into the, if I convert this expression into English statement, it means for some number x, either it is real or it is rational. But the statement here given, it is not same like this. यहाँ पे बोला है कुछ रियल नंबर रेशनल है, बट इस एक्सप्रेशन के मुताबिक वो है कि कुछ नंबर है जो हो सकता है रियल है या फिर रेशनल है. ऐसा नहीं है, यहाँ पे चाहिए कुछ रियल नंबर है जो रेशनल है. दैट मीन्स वी कैन कंसीडर कि कुछ नंबर्स है जो रियल भी है साथ साथ रेशनल भी है. So if these things are happening together, so that means we should use conjunction between them. So in place of this disjunction, if I use now conjunction, I think this is the correct expression for the given statement. Some real numbers are rational. Okay. So from there, you should remember those things, that the existential quantifier cannot take a conditional symbol, conditional expression, and also this statement is having some part like sum. That means whatever the expressions are, whatever the condition, whatever the things it is containing, it is not for all, it is for some. So there should be an existential quantifier, not the universal quantifier you should write. Got it? So this is one question. Okay, so this thing we have already done. This is a very simple thing. इसमें कौन सा मिसिंग है बहुत आसानी से बता सकते हो. 2 to 3 12 कितना है, 6 मल्टीपल है, फिर 5 है, फिर 4 है, 3 है, 2 है, तो 1 होगा. तो 1 मल्टीपल ऑफ 1440 इज दैट नंबर इटसेल्फ. ये तो बहुत सिंपल ही है. अच्छा, फिर ये सब हम लोग कर लिए हैं. हाँ, यू कैन चेक दिस वन ऑल्सो कि बोला है सिमिलरली. ओह, दिस थिंग वी हैव ऑलरेडी डन, राइट? आज तो ही किए हैं पहले, इससे पहले जस्ट किए थे. So we have maximum things have done. This thing is there, so that kind of problem you may get. So अब देखते हैं कि इसमें ऑप्शन क्या हो सकता है. ओके, okay. So question is this, that two statements are given and corresponding to these two statements some conclusions are also given. Question is, if we consider these two statements together, can we conclude anything? The two conclusions are given, just you have to check which conclusion will be true from here. Okay, just a minute. So if we do one thing, that if we write the statements in terms of its logical form, I think it may be possible to solve these problems. Otherwise, what you should do for this kind of problem, you should take the Venn diagram जितना possible हो सकता है. जैसे कि दो स्टेटमेंट दिया है, एक है ऑल बैक्टीरिया माइक्रो ऑर्गेनिजम्स, राइट? तो ऐसा हो सकता है तुम्हें कि ऑल बैक्टीरिया माइक्रो ऑर्गेनिज्म, तो ए अगर बैक्टीरिया है तो इसको तुम रखो माइक्रो ऑर्गेनिज्म, तो सारा का सारा बैक्टीरिया देखो माइक्रो ऑर्गेनिज्म के अंदर आ रहा है. सेकेंड वन है ऑल पैथोजेंस आर माइक्रो ऑर्गेनिज्म, तो ए रखो तुम पैथोजन, वो भी सारा के सारा माइक्रो ऑर्गेनिज्म के अंदर आ रहा है. अब बात ये है बी और पी में आपस में कुछ रिलेशन है कि नहीं, वो तुम 4 वे में ढूंढ सकते हो. जैसे कि एक मान लो जहाँ पे एक के अंदर एक है, बी के अंदर पी है, और एक ऑप्शन लो जहाँ पे पी के अंदर बी है, मतलब पी सारा बी कंटेन कर रहा है. और एक ऑप्शन लो जहाँ पे बी और पी टोटली डिसजॉइंट है, और एक ऑप्शन लो जहाँ पे उन दोनों के बीच में कुछ कॉमन है बट नॉट ऑल कॉमन। तो ऐसा 4 ऑप्शन लेके तुम चेक करके देख सकते हो उनमें से कौन सा कॉन्क्लूजन करेक्ट हो रहा है। बट इस प्रॉब्लम के लिए एक्चुअली लॉजिकल स्टेटमेंट यूज करने से ही हो जाएगा। लाइक गिवन दैट all bacteria are microorganisms, so if we convert this into the logical statement, I can write in this way: for all living organisms, if it is a bacteria, then it is a microorganisms. I hope you can remember these things. How can we convert any statements into its logical form? तो ऐसा सोच सकते हैं कि अगर हम लोग सारा के सारा लिविंग ऑर्गेनिज्म का सोचेंगे, तो अगर वो बैक्टीरिया है तो माइक्रो ऑर्गेनिज्म है, इसका मतलब सारा के सारा बैक्टीरिया माइक्रो ऑर्गेनिज्म है। यू कैन राइट इन दिस वे। सेकेंड वन है कि सारा पैथोजन माइक्रो ऑर्गेनिज्म है। सिमिलरली सब लिविंग ऑर्गेनिज्म के लिए यहाँ पे सारा लिविंग ऑर्गेनिज्म के लिए अगर वो पैथोजन है तो वो माइक्रो ऑर्गेनिज्म होगा। दिस वन। Now here these two statements are happening together, तो ये दोनों के conjunction ले लो। After that I told you that universal quantifier is distributive over conjunction, तो दोनों में अगर universal quantifier है and they are connected by conjunction, so I should take this universal quantifier out and I can connect these two expressions by conjunction. So I can do that thing. This will be same as for all x, same as for all x, bx implies mx, conjunction px implies mx. Okay. Now as I told you, best way is that always write the expressions in terms of the 3 basic operators, that is conjunction, disjunction and negation. Since here we are getting implies or conditional connective, so I should write in this way: negation of bx, I mean, or mx, you know, p imply q means what? Negation p, disjunction q hota hai. That thing just I have taken. Conjunction I am taking. Similarly, another conditional statement is there. I should write negation of px, disjunction mx. Okay. Now both these expressions is having disjunction mx as common, so take that thing out. I can write for all x, then if I take the disjunction mx out, अगर इसको पूरा बाहर कर दिए तो the remaining things what we are getting here वो देखना है। ओके, तो बाकी क्या बचेगा? यहाँ से बच रहा है नेगेशन ऑफ bx, कंजंक्शन तो है वो साथ में आएगा, और यहाँ से बच रहा है नेगेशन ऑफ px. So basically I have used the reverse distributive law to get that thing. After that what I can do, I can take negation out from these two. तो negation अगर बाहर लाएंगे, you know, by based on the De Morgan's law, this conjunction will be converted to disjunction. So I can write bx disjunction of px, and there should be disjunction of mx, right? So basically we are getting the form where we have got this one, negation of this, disjunction this. So that means what? That means this implies of that one. So bx disjunction of px, this whole thing will imply something, that is m of x. This one. Now let us check the conclusion. Given is some pathogens are bacteria, but here from this expressions what we are getting, that the relations are between bx and mx or px and mx. there is no certain relation you can find between these two. इन दोनों के बीच में कोई रिलेशन है नहीं। वो लिखा है कि Bx या फिर Px होने से Mx होगा, मतलब बैक्टीरिया या फिर पैथोजन होने से ही माइक्रो ऑर्गेनिज्म होगा। बट बैक्टीरिया और पैथोजन इन दोनों के बीच में कोई भी रिलेशन नहीं है। सो इफ इन द any relation between them, definitely they are false, they are incorrect. Like first one is given as some pathogens or bacteria, so definitely you cannot conclude from here anything, क्योंकि इन दोनों के आपस का कोई भी रिलेशन डिफाइन नहीं है। यू कैन नॉट गेट फ्रॉम द स्टेटमेंट्स। सेकेंड वन से भी कुछ नहीं मिलेगा, ऑल पैथोजेंस आर नॉट बैक्टीरिया, यहाँ से भी तुम्हें कुछ भी नहीं मिल रहा है। सो दैट मीन्स इफ दिस टू स्टेटमेंट्स आर गिवन, we cannot get any conclusion between these two things, the bacteria and the pathogens. So option D will be correct, where conclusion 1 or 2, neither of them are correct. But my suggestion is always here as a statement it is giving that both the things are given in the form of universal quantifier, all are given. but मान लो कि एक में all है एक में some है, तो उसके लिए क्या करना है? So then definitely you should not go through like this, because then you cannot merge them. दोनों को एक साथ combine नहीं कर पाओगे। यहाँ पे universal quantifier था दोनों में, तो इसलिए merge कर दिए। So if one is having universal quantifier, one is having the existential quantifier, you cannot merge them together. So the best way is if you take the Venn diagram, वहाँ पे लिखने लगता है क्या होने से क्या होता है, जो ऑप्शन रहता है उसके हिसाब से तुम वेन डायग्राम बनाओ। जितना पॉसिबल केस आएगा, टेक एवरी पॉसिबल केसेस, उनमें से तुम्हें चेक करके देखना है कि उनमें से कौन सा कॉन्क्लूजन करेक्ट आ रहा है। दैट विल बी द वे टू डू दैट। दैट इज नॉट, मैंने जो ये किया लॉजिकल एक्सप्रेशन यूज करके किया, बट ये इफिशिएंट नहीं है, क्योंकि ये हर बार काम नहीं करेगा। अगर स्टेटमेंट जैसा है उसके हिसाब से तुम्हें खुद अप्रोच, जैसा कैसा अप्रोच है वो तुम्हें डिसाइड करना है, इससे नहीं होगा हर बार। ओके, अच्छा, एनीथिंग, एनी क्वेश्चन, एनी डाउट इफ यू वांट टू आस्क? Okay, anything? No problem. So let me check if we can find any other things. Like one question you are getting here, as I told you, this rule of inference, right? They are very simple thing to remember. I have actually forgot. I think I have taught it one or I think I have taught your batch. This is 2021 batch, right? So I think I have taught you, maybe not in your section, but I have taught this thing. So I have forgot all the name of the rules, but I can remember the rules. So in the next class, I will come with the name of the rules also, and I'll explain that how we can use and how we can check whether any conclusion is correct based on the hypothesis, right? तो कोई भी जो आर्गुमेंट होता है, आर्गुमेंट में दो पार्ट होता है, एक होगा कंक्लूजन, एक है हाइपोथेसिस। सो जो हाइपोथेसिस है, हाइपोथेसिस में डिफरेंट रूल्स ऑफ इन्फरेंस यूज करके कैसे कंक्लूजन तक जाना है और whether the conclusion is correct or not, वो कैसे चेक करना है, we have to do that by using defined inference rule. Inference rule. Like I can remember few one, like one is modus ponens, one is modus tollens, one is hypothetical syllogism, one is conjunction, one is addition, ऐसा कुछ रूल्स था। तो रूल का तो नाम याद नहीं है, बट रूल से ढेर सिंपल कुछ तो ऐसा था कि P होने से अगर Q होगा, एंड मान लो P हो रहा है तो डेफिनेटली Q होगा, राइट? एज ए कंक्लूजन वी कैन गेट दैट। मान लो कि ऐसा है, P होने से Q होगा, और मान लो Q नहीं हो रहा है तो डेफिनेटली P नहीं हुआ है, क्योंकि P होने से तो होता था Q, Q हुआ नहीं मतलब P भी नहीं हुआ है, राइट। और एक ऐसा था कि P होने से मान लो Q है और Q होने से मान लो R हो रहा है, सो डेफिनेटली P होने से R होगा, ओके। ऐसा था, मान लो कि P हो रहा है, P डिसजंक्शन Q हो रहा है, तो अगर A हो रहा है मतलब आइदर P होगा या फिर Q होगा, बोथ आर करेक्ट, इनमें से कोई भी हो सकता है। एक था P एंड Q दोनों हो रहा है, सो वी शुड से P डिसजंक्शन Q, P कंजंक्शन Q, दैट कैन हैपन। ऐसा भी और भी 3 रूल था, 8 रूल था मोस्ट प्रोबेबली। So I have forgot that. The next class, I think tomorrow, I'll come with all this rule of inference. But ये क्वेश्चन के लिए ज्यादा कुछ नहीं चाहिए, दैट्स अ वेरी सिंपल थिंग, ये तो बहुत आसानी से हो जाएगा। बट चलो कल देखते हैं, कल जितना हो सके एमसीक्यू हम लोग सॉल्व करेंगे, बट नॉट ऑल द एमसीक्यूज, बिकॉज यू कैन सी द प्रॉब्लम यू कैन फाइंड लाइक दिस ऐसे, बट इनमें से सारा प्रॉब्लम सॉल्व करने का जरूरत नहीं है। हमें वो सब प्रॉब्लम चूज करना है व्हिच विल बी इम्पोर्टेंट फॉर एप्टी टेस्ट। तो नॉर्मल क्वेश्चन सॉल्व करने का कोई मतलब ही नहीं है, ऐसा क्वेश्चन देखना है जो कि तुम्हारे एप्टीट्यूड टेस्ट में आ सकते हैं, ऐसा क्वेश्चन देखना है। तो क्वांटिफायर का जो पार्ट बताया दैट इज क्वाइट इम्पोर्टेंट, एंड आफ्टर दैट दिस पोर्शन, दिस combinations and permutation and combination, these things are very important. You have already, if you have attended any of the aptitude test, mock test even, you can see that the questions from combinatorics, combinations and permutation, then definitely you will get that kind of questions, and more questions you will solve, more you will get the things. बहुत सारा वहाँ पे रूल्स वगैरह होता है, कॉन्सेप्ट भी बहुत सारा चाहिए, तो जितना ज्यादा प्रॉब्लम सॉल्व करोगे उतना तुम्हारे लिए अच्छा है। Like this thing, mathematical induction, we don't need any question from here, क्योंकि ये मुझे नहीं चाहिए, इसमें से कुछ नहीं होगा, इसमें आएगा नहीं। बट हमें वो सब क्वेश्चन करना है, जैसे ये सब क्वेश्चन कॉम्बिनेटरिक्स का ऐसा है कि ऐसे मल्टीपल चॉइस क्वेश्चन है, 15 क्वेश्चन है पेपर में, जहाँ पे ABCD ऑप्शन हो सकता है, तो नंबर ऑफ डिफाइंड वेज ऑफ आंसरिंग द क्वेश्चंस पेपर आर हाउ मच, तो ये सब क्वेश्चन आ सकता है, राइट। That thing we'll discuss in the next class. It's already 3:59, so we should stop here for today. So see you tomorrow. Thank you very much, and that will be our last class. So if you have any doubt regarding discrete mathematics, you can ask me in the next class. Okay. Thank you very much. You can leave the meeting now.